Welcome to Homework Lib.
Hi, so in this case what we're going to have is a weak acid that is going to react with a strong base, right? So the first thing that we need to do is to know the amount of mole of the weak acid that we have, and that is simply doing the multiplication of the volume in liters. That's why I put the times 10 to the minus 3 factor directly by the concentration that we have, a zero point 0.3 molar concentration. So this is going to be 6 times 10 to the minus 3 mole of HBRO. And then we're going to calculate the amount of OH minus that we added. That amount is the same thing, 40 times 10 to the minus 3 liters times 0.15 molar. And guess what? In this case, we have added the same amount of both of the substances. That means that we're going to reach the equivalence point. So let's go ahead and do our ice table. Here I'm going to consider a final volume that is 40 milliliters plus 60 milliliters. So 60 milliliters or 0.06 liters, right? So for our ice table, the reaction that is going to occur is, first of all, the weak acid with the strong base is going to produce the associated conjugate base, BRO minus, plus water. The initial amount, here it really doesn't matter because we have the same value, 0 and 0. And this, all of this ice table is going to be in mole. The amount of change, also in mole, is the same for both of these compounds. And plus 6 times 10 to the minus 3 for my conjugate base. And at equilibrium, I have close to 0, and 6 times 10 to the minus 3 mole, right? So at equilibrium, my concentration of BRO minus is going to be equal to 6 times 10 to the minus 3 mole divided by my 0.06 liters, right? 0.06 liters. So we have a zero point 0.1 molar concentration of the conjugate base. So how do I calculate the pH from this information? We need to consider the opposite reaction of the dissociation of an acid. In this case, we're going to use the basicity constant for this compound. This is going to generate OH minus plus HBRO. Correct? The initial amount, now this ice table is going to be in molarity. The initial amount is 0.1 molar. Water doesn't matter because it's a pure substance, and we start with 0 of each. Next up, what we're going to have is the amount of change. We're going to call it X. An X portion is going to react with water in order to generate X of both sides. So at equilibrium, we're going to have 0.1 minus X, X, and X. With this, we can use the basicity constant that is defined as concentration of OH minus times the concentration of the weak acid divided by the concentration of the conjugate base. For our case, this is going to be equal to X divided by 0.1 minus x, which is simply x squared divided by 0.1 minus x. So now, if we know the value for kb, we could solve the quadratic expression to know the value for x. And that value for x is going to tell us the concentration of OH minus. We can also do an approximation, but first of all, let's calculate kb. Remember that Ka times Kb needs to be equal to Kw, right? So Kb is Kw divided by Ka. In an alternative way, we can find the value for Ka and for Kb using the relationship with pKa and pKb. That depends on which quantity you're given. In this case, we're given directly the Kw, the Ka, so we can go directly through Kw and get the result. So for this problem, the value for Ka is equal to, it doesn't show up, unfortunately, in the question, but let me look it up. So the value that I found is of 2.5 times 10 to the minus 9 for ipobromous acid. But you should replace the value that you're given directly here, right? So, for example, in one table I found 2 times 10 to the minus 9, in another 2.8 times 10 to the minus 9. So, verify the value with the question that you had. So, with this, the value for Kb is directly 4 times 10 to the minus 6. Now, with that out of the way, we can replace the value for Kb in our equation. 4 times 10 to the minus 6 is going to be equal to x squared divided by 0.1 minus x. If x is much smaller than 0.1, the result should be that x is going to be lower or equal than 5% of 0.1. Okay? If that is true, we can approximate this by x squared divided by 0.1 directly. And we can quickly see that that is going to be true. X squared is going to be 4 times 10 to the minus 6 times 0.1. We can take the square root on both sides, and we get this nice equation for x, which gives us 6.32 times 10 to the minus 4. But what is the value for that x? Remember that x was the concentration of OH minus, right? So this is equal to concentration of OH minus. That means that POH is going to be equal to 3.2, essentially. And using pH plus POH equals 14, we can know that pH is going to be 14 minus 3.2, which is 10.8. And this is going to be the pH at the equivalence point for this weak acid strong base titration. And that would be all. Thanks so much.